X, there's a plate Y, and initially they are neutral. So first I'll give a charge Q. Q and minus Q I'll get. So where do this charge? It will decide here. Okay, let's come for what we have to calculate the potential of this capacitor. No? So how the electric field between the plates will be in this direction. Can you remember some method I told you? There are the surfaces like 1, 2, 3, 4, 5, 6, 7, 8. So the field due to this will be in this direction. What about the field due to this is a negative 1? The field will be like this. So what is the net field at somewhere this E bar is needed? Somewhere at point P1 I want. At point P1. What is the point P1? Between the plates. P1 is what? Point. What is the electric field at that point? Let it be E. Who will contribute electric field at point P1? I think, shall I say only 4 and 5? What should be the E4? There's a conductor, no? Then what is the basic idea? When you're calculating the field, we don't have any formula for field due to conductor. Each side, each face of a conductor what happen will behave like a non-conducting sheet. So therefore, what should be the E4 value? The E4 value should be equal to how much? Sigma by 2 epsilon naught I cap. Sigma by 2 epsilon naught I cap. So the resultant field will be E equal to sigma by epsilon naught. So direction towards right. What is sigma? Charge by area. So I'm writing now Q by A epsilon naught. Okay, and this field will be uniform, no? We know already from Gauss law. What is the potential difference Vxy? You're going to write, let D be the separation between the plates. E into D. From electrostatics, what is the potential difference in uniform electric field? Electric field into the distance of separation between the plates. So what is E value? Q by A epsilon naught. This is D. How we define capacitance? The capacitance of system, we define charge by potential difference. So this Q by, so the capacitance of parallel plate depends on what all? What is a area of cross section of plates? What is a area of cross section of plates here? And what is D? D is the separation between the plates. It's a very popular what all use applications. No, parallel plate is what preferred. Cylindrical is what we usually use. Parallel plate capacity is on paper, only theoretical. I think I'll make clear. Parallel plate capacity is what? Only on paper. Only theoretical idea this is. What all we use applications are cylindrical capacitor, which is not part of syllabus. Just will derive an expression for different shaped structures. What is the capacity? Like how we had in resistance. No? Similarly, we'll work out few problems here. It's only theoretical. It's just a theoretical proposal, parallel plate. We don't use it anywhere in the application. But to learn capacitor, this is the best thing. All the concepts open, we can learn clearly with the help of parallel plate. So only on paper, we are in paper world will be there. Practically, the cylindrical capacitor is what we use for application. I'm making some things clear for you. Nowhere you are going to use this practically. Okay, let's come for that. This is about the capacitance. Again, you see it doesn't depend upon the capacitance. It depends on physical parameters, shall I say? The capacitance of conductor just depends on physical parameters. So for electrical connections, we do give these are. So what are these knobs? For electrical connections, now I should use somewhere in the circuit. So like this, I'll provide a connection. These are called like leads. So this is one basic idea of a parallel plate capacitor. What about the energy stored in this capacitor? Again, it can be equal to U equal to Q square by 2C. Any of the formula you can apply it. Okay, next question comes. How to use this in practically? For that, what we should do? We should give equal and opposite charges. So shall I take some bottle which contains the charge, positive charge in this bottle. Then I'll take a spoon, plastic spoon, because how to add a charge? Like how we had a salt, like this, can we add a charge to this one? Like a sprinkle. I'll take a spoon, so I'll fill up that positive charge, then I'll pour it. Can we do like that? Not, it's not like a some adding some sprinkling some salt on the dishes, adding charge to a conductor. So very next question comes. Okay, this is about the capacitor. Like if you say bucket, how to add water to a bucket? So definitely what you see, I'll open the tap. And what is the tap? Tap is some sort of source of energy, no? So similarly, so I should take help of some source. So through that source, I can add energy to a capacitor, because what is the basic purpose of capacitor? It has to store energy. Sir, where is energy is present? So I'll directly come for the formula. U equal to energy stored. It should be equal to energy density into volume. So what is energy density? Of epsilon naught E square into AD. Whether I'm right or wrong, I'll come like this, into AD. So finally, what is equal to? This will be Q square by 2 epsilon naught A by D. After solving all this, I ended up with a formula like this. So what is energy stored in the capacitor? Charge by capacitance. And nothing but another formula, energy density. What is UD? UD is energy density. Go back to the electrostatics. If the field is uniform, then what we do? Energy density into volume. Where all field is present between the plates of capacitor. What is the volume? A into D. So finally, I got the same answer, Q square by 2C, or if you want using energy density, you can find out. So what is the energy of a parallel plate capacitor? Either use this formula or energy density formula. The plate Y is earthed, so you'll get confused here. So therefore, I just put positive negative charge. We can't give this positive negative charge. What is the best method? To earth it. The plate Y should be earthed. So to that, because of earthing weapon, it acquires negative charge. I'm directly showing it here. But practical weapon, we can't give charges like this. By earthing only, the charges will be like this here. To just have a basic idea, because the earthing means again you start thinking some other way. Potential of Y will be 0. That's all. If you want, I'll introduce the earth. I'll introduce the earth. No problem. Everything will be same. Earthed conductor. It is. So even if I remove it, doesn't matter, but it'll be very easy for me if I do earthing. Just if I give charge to plate X, the problem will be solved. Then I should not give this particular negative charge. Okay, since we know most of the Gauss law, no, the plate X is given a charge. So finally it comes this. If I don't have this earthing, then definitely what I should show minus Q. What the idea? It's left to you, which one you feel convenient. But the basic definition, if you want, from that, I'll bring earthing. Somebody asked like this. Okay, I'll retain it. Then plate X is given charge Q. Then what I should write? Only plate X is given a charge Q. Good idea. So it should be like this. Or both the plates are neutral, then they're given charge Q minus Q, then we are discussing the condition. Minus Q charge has come due to induction, due to electrostatic induction it has come. So I'll write it here, minus Q is due to electrostatic induction. So